Hi guys, my name is Harry. In this lesson, we're gonna learn how to find the solution to a homogeneous nonlinear second order differential equation given that we have one solution to that differential equation. The question reads as follows. Find the general solution and a second solution of x squared y second derivative minus 3xy first derivative plus 4y is equals to 0, given that first solution, y1 of x is equals to x squared. In order for us to determine the general solution as well as the second solution, we're going to use the method of reduction of order since we are already given the first solution to this nonlinear ODE, which is y1 of x is equals to x squared. The method of reduction of order is going to help us reduce this nonlinear ODE to a linear first order differential equation. We're going to start by assuming that our general solution y of x is in the form of u multiplied by the first solution y1 of x. Therefore, the general solution y1 of x is going to be given by u multiplied by x squared. Then we're going to continue and find the first derivative and the second derivative of y of x. The first derivative of y of x is going to be u prime multiplied by x squared plus 2u multiplied by x. And then the second derivative, y double prime of x, it's going to be equals to u double prime multiplied by x squared plus 2u prime multiplied by x plus 2u prime of x plus 2u. And then the next step, we're going to substitute y of x, y prime of x, and y double prime of x into the given ODE. So that will be x squared multiplied by y double prime, which is u double prime of x squared plus 2 u prime of x plus 2 u prime of x plus 2u. And then minus 3 of x into y prime. And then y prime is u prime x squared plus 2u of x, close bracket, and then plus 4 into y, which is ux squared, close bracket, is equals to 0. Let's simplify. We're gonna have we multiply out the brackets. So we're gonna have x squared multiplied by u double prime x squared. That will be u prime x to the power 4, and then plus, you can notice that we have the like terms here. So this is going to be 2 plus 2, that is 4, u prime of x multiplied by x squared. This will be 4u prime x cubed, and then plus 2u x squared. And then we're gonna have minus 3u prime x cubed plus 2u, not 2, but this is going to be minus 3 multiplied by 2ux. So this will be minus 6ux squared. Then plus 4ux squared is equals to 0. And then let's see if we can cancel out any like terms. So we have u prime x to the power 4, and then plus we have like terms, this and this. So this is going to be 4u prime x cubed minus 3. That will be plus u prime x to the power 3. And then other like terms, we have 2ux squared minus 6ux squared plus 4. So 2 minus 6, that will be minus 4ux squared plus 4ux squared, which is just 0. Therefore, we're going to have u double prime x to the power 4 plus u prime x cubed to be equals to 0. Then from here, we're going to reduce this equation to a first order linear differential equation by letting, we can take any letter z, and then we let it to be equals to u prime. Therefore, this tells us that the first derivative of z prime will be equals to the second derivative of u. Now let's go and substitute in our equation. So we're gonna have z prime x to the power 4 plus z multiplied by x cubed is equals to 0. And then from here, we can divide by x to the power 4. Therefore, we're going to have z prime plus 1 over x multiplied by z is equals to 0. Now we can notice that we have a homogeneous linear first order differential equation. So since this is a homogeneous first order differential equation, we can simply use the method of separation of variables in order for us to find the general solution to this linear first order ODE. So let's continue and determine that. So that is going to be z prime is equals to minus 1 over x by z, and this is our function in terms of x. So z prime is simply the change in z in terms of x, which is going to be equals to minus 1 over x z. Now let's group the like terms. I will divide by z on both sides and multiply by dx on both sides. So I'm gonna have 1 over z dz to be equals to minus 1 over x dx. Now let's go ahead and integrate both sides of the equation. So when we integrate both sides of the equation, we get that the ln of z, is equals to minus the ln of x plus our constant c. Therefore, we're gonna introduce the e to the power ln c. It's equals to e to the power minus the ln of x, and then plus e to the power c. Therefore, this is simply c is equals to e to the power ln of x to the power minus 1, and then multiplied by e to the power c. So this is going to be equals to c is equals to x to the power minus 1, and e to the power c, we can call it just a constant k, since this is just a constant. Therefore, our z is going to be equals to k over x. From here, we can now remember previously we said that z is equals to u prime. We said that z is equals to u prime. Therefore, we can equate u prime to k over x. Let's continue and do that. So u prime, we equate it to k over x, and the u prime is same as the change in u over the change in x is equals to k over x. Then we can group the like terms. Du will be equals to k of x dx, and then from here we integrate both sides. So we're gonna get that our u is equals to k multiplied by the line integral of 1 over x dx. Therefore, our u will be equals to k ln of x plus our constant. So now we found our u. Therefore, we can then now write our general solution. Remember, firstly, we assumed that our general solution is in the form of u multiplied by x squared. Therefore, this tells us that the general solution to this given nonlinear ODE is then going to be y is equals to u, which was found to be k ln of x plus c1 multiplied by x squared. Therefore, our y of x is equals to, we can multiply out the brackets, k x squared ln of x plus c1 x squared, right? C1 x squared, and this will be the general solution to the given ODE. Now, what will be the second solution? We know that by the method of variation of parameter, the particular solution is given by u1 y1 plus u2 y2. Hence, in this case, we can notice that our first solution is basically this, which will be y1. Therefore, our second solution is basically x squared ln of x. Hence, the second solution y2 of x will be equals to x squared ln of x, and that is the second solution. Now we have answered the question. Thank you.